afternoon. We're kind of back down to some stratocumulus, and you can see that here. The base is on these clouds at about 6,000 feet. And you can kind of differentiate that then from altocumulus because the shading on the underside of the elements is a lot darker. And typically we see these under 6,500. In fact, that's the universal definition, 6,500 feet above ground level. If you go below that, you're dealing with stratocumulus. And speaking of clouds, last night we talked about salamaters. This is the one at a AWOS site, and this has a range up to 25,000 feet. And I wanted to show one photo, thanks to Fred Reamer. He sent in a picture of a salamater right here on his desk. Man, Fred, where do you get these things? eBay, or I guess you're working at a university there, so maybe you've got a sample model there, but it's very interesting. I would love to hook up one of these here and play around with it, but maybe one of these days I'll get a chance to do that. Here's what a salamater actually sees. This is kind of a rare diagram. This is kind of like the function of time, increasing time. So basically it shoots a pulse of light energy up, and it's sort of like radar. So you can see there's kind of a power curve here, and when it's passing through precip, you have this very gradual increase. And when you hit a cloud base, we used to call this taps, like you're tapping a cloud base there. And that would be considered the height of the cloud. So you're looking strictly at cloud bases, not the tops. If you want to get cloud top data, you have to go to PIREPS or satellite data. And this is a quick look at a salameter unit right there. Kind of like a big light right there. It is. It's actually an infrared lamp right there. Okay, on with the weather. We've got some storms up in the Central Plains and the Midwest. From Iowa down to Omaha, through almost to Topeka there and passing Salina. That's along a front right like that, and you can see in the clear air back in Colorado, you can still pick up that front right here. Even if you don't have surface observations, you can use that radar data to pinpoint that, and you kind of blend that into your analysis. And another source of data is satellite imagery. And I don't have any frames that go far back enough. The air mass is actually kind of dry through this region right here. But if we were dealing with a more humid air mass, we would likely be able to track the progression of this front as far back as dawn, and maybe even the previous day. So here we can see in Kansas the development of that line of thunderstorms here. I believe the radar or the satellite is trying to animate here. I'm trying to figure out what's going on. There it goes. Very cool there. You can see it's kind of a pretty much a quasi-stationary front, maybe a little bit of forward motion, and you got this other cell back behind the line. And this is going to be a higher base storm. We can take a look at the dew points there on the surface chart and see what's going on. This is going to be out around Colby, maybe. Okay, before I go any further, let me go ahead and freeze this so it doesn't use up bandwidth, and I'll see what's going on in chat here and make sure the audio is looking good. Okay, got quite a crowd here tonight. We've got Andrew and Mark, always the same gang of people. I appreciate you watching every day. Kind of makes me look forward to coming back here. Fred Reamer is here, and yeah, I appreciate that salameter photo there. Justin Pulliam is here, Sue M, and Justin was watching some videos from 2 years ago. Yeah, I don't know exactly when these... I mean, I've got videos going back many years, but I wonder when the first webcast was, when the first nightly webcast was. I think they were recorded I think maybe in January of 2015, something like that. A long time ago. Ahmed here, and Fun with Tech, and Tom J, Alexi, and I don't know if I mentioned it, Lexi, but I appreciate your Patreon donation. That's a big help there. Mike Estwick is here, or let's see, did I mention Mike Estwick? Okay, and Victor Cabot and Ryan Toomies is here. Justin says the audio is low, and I noticed that on my meters too. Let me take a quick look here and see what's going on. See, it's going to be under that. Levels 100. I think maybe the system just needs to be rebooted or something, but I can just bring up the levels here. There we go. Let me know how that is right there. Still looks a little bit low on my meter. I'm not too sure what's going on there. Okay, let me move a few other levers here and get things going. Okay, still looks a little bit low on my end, but hang on a second. I got something funky going on with my board here. I just saw my sliders go down on their own. Okay. All right, let me know how that sounds. I'm sorry about the delay there. I should have checked that out before we went on the air. Okay, Dorothy Tornado is here, and let's see here, Andrew. And Mike says the front has clouds over the Rockies and sharply cooler in Denver. Let me show you those satellite imagery here real quick. This is from a little bit earlier today, and you can really see that region of storms, or that front coming up to the north coming through. You can see it coming together right there, just right around the Lincoln area down to northern Kansas right there. So this is what the environment looked like about 1 or 2 p.m. before things got going. So if you were chasing on this day, this is kind of the setup you'd be looking at. We've got stratocumulus bands. This is kind of the moisture field out ahead of the line of storms. And you see that it looks kind of dry out ahead of this line here. So that's kind of a negative factor in today's situation. The last thing that I like to see is the low-level cloud field disappearing. That's always a bad sign. Let me play that a little bit here. It's going to be flashing here for just a second because it's buffering the frames into memory. Now it's going to be a little bit smoother. So here we can see the progression of development today. Very spectacular there. These are always fun to look at. And you can see the elevated storms out in Colorado. This is due to the upslope flow out in this area. A little bit of moisture and higher dew points. You have parcels moving from 2,000 up to 4,000 feet. And you have the approaching instability from the west. So these are kind of moving eastward and catching up to the main line here. Okay, a little discussion about the audio in chat, and Carl checking in here. Thomas says it's been a cool, wet day in Virginia. Dwayne Ward says cloudy and 56 on the Delmarva. Sarah says, don't forget to hit the like button. Yeah, definitely do that. I appreciate that. Tornado warning posted for Iowa. Yep, I've got GR level 2 ready to go. We'll check that out. Radar indicated rotation. And Mike Wan has just joined us. There it is. There's a tornado warning for Carroll County. I don't know that area very well. That's little, it's probably about 70 or 80 miles west-northwest of Des Moines, way out there in the Corn Belt here. There's the storm there. Any idea where the tornado is based on this reflectivity? Pick off the boxes here. Yeah, if it was the 1980s and you were dealing with the old WSR 57 radars, you would really have a hard time looking at this and trying to figure out whether a tornado is on the ground. And there used to be a lot of busts back in the 70s and 80s where tornadoes were completely missed. And I want to say Sweetwater, Texas in 1986 was one such example. Well, we do see a little bit of reflectivity gradient on the north side, but really not much else to go off of here. So let's go to storm relative velocity. Well, we've got some range folding in here. So that's a problem right there. Sometimes you can minimize the storm relative, or I'm sorry, you can minimize the range folding by going up to another tilt. In this case, not much help. So in this case, we are kind of close to the Des Moines radar, so we can load that up. Why don't we take a look at that? Let me get Des Moines going. Okay, so Des Moines radar is coming in, and there's our webcam checking in there. Okay, Ryan mentioning Des Moines radar has the better velocity for the cell. Yeah, there. So we're just waiting for that data to come in here. While that's coming in, we'll take a look at one other chart here. Let me go back to my sequence. And there's that slight risk for today, and you can see we've got a tornado watch box for southwest Iowa and severe thunderstorm warning for north central Kansas there. Storm reports, we don't have too many of those coming in yet. Mostly a lot of hail reports from about the Lincoln area down to about Great Bend. Now, what kind of instability are we looking at today? This is the SPC Mesoscale Analysis page. It's spc.noaa.gov/exper. And we can go to the Thermodynamics tab here. And on a day like this, I think maybe 100 millibar mixed layer would be a good solution. Figure out the instability. So there it is. And remember, we don't want to actually look at the values where the storms are themselves. We want to kind of look out ahead a little bit in the environment, in the moist sector. So you can see we're looking at values of about 1,500. Now, a good rule of thumb here is 1,000 is starting to get up into strong thunderstorm territory. 1,500 is severe, and 2,000 to 3,000 is going to be associated with your large hail and tornadoes. And there's been a couple of very severe situations. I think, I want to say that large Nebraska hailstone with the 6 inches, I think we had like 4,000 or 5,000 on that storm, and I've seen up to 7,000 or 8,000 in Bangladesh. This time of year, they get some very incredible instability there. Okay, Des Moines is not coming up for some reason. Still showing downloading. I think I'm going to restart GR Level 2 here. I don't know what the problem is. Okay, while we're waiting on that, let's look at the upper air patterns. No, let's fix GR level 2. Okay, let's do that. Give me just a second here. Okay, I'm clicking on Iowa, Des Moines. Try to get that going one more time. Okay, so the pattern that we have right now, kind of a zonal upper air pattern. So the polar front jet extending from central California to about Denver and into the Omaha area. So there it is, a higher wind starting to nose in, which means height falls and destabilization. And then here's that old segment way up to the north in Canada. So we're starting to break down the ridging here in the plains. So there's the ridge right there, and here's the height falls coming in, and here's one trough right here, kind of a negative tilt trough there. So we got about 70 knots here at 250 millibars. 500 millibar flow looking like this. About 30 knots at 500 millibars there. Do we see any short waves? Yeah, I see one right here. They are very hard to find at 500 millibars because we're talking about scales on the order of 50 to 500 miles. So that right there, that's about the size of a typical shortwave, a true shortwave. And that's a shortwave trough. We also have ridges, so there's probably one right there. And I see a shortwave ridge right here. So you see, these things are very small scale. They're very subtle features. And we really have to use tools like model diagnostics to really pick those out. So there's an example of a diagnostic we would use here. There's this morning's 12Z pattern. And I can pick out that shortwave right here over Colorado. Maybe another one right there. And where we have an absence of shading, we have a ridge, shortwave ridge. So there you go. That would be a shortwave ridge kind of buried in there. And I find a lot of sites are not very good for presenting a good color scheme for vorticity. I find that like the INSEP page for the model output, I find it very hard to pick out shortwaves with the color scheme that they use there. This one is probably one of the better ones here. You can see that they kind of miss. It misses the part of the color scheme that deals with the ridges. So I don't really like that a whole lot. Okay, back to GR level. Okay, GR level 2 is not working out. Tell you what, guys, I'm going to load up GR level 3, which I have not done in about a year. Find GR level 3 here. Now, GR level 3 uses level 3 NexRad data. And this is a type of data that is focused more on generated products rather than the raw base data. Got the Iowa radar, Des Moines, and we should get this data up relatively quickly. Okay, loading. There we go. There's our radar data. So let me get rid of these boxes here. There we go. So there's our storm right there. This uses the classic base reflectivity, so the data is a little bit coarser. But anyway, that's our storm right there, and you can see we've got a bit of a bow echo appearance going right there, kind of a convex shape. So that's going to be a little bit of concern right there. It kind of tells us that there may be a lot of outflow generation in the storm, possibly some high winds. Let's look at storm relative velocity. Let's see, what do we got here? I don't have the previous products, so what we're seeing here, this is velocity outbound from the radar, this is velocity in, there's velocity out, and this is stronger velocity. And this is not the optimal color scheme to be using, but I can kind of pick out this right here. This looks like a little bit of rotation right there. Now let me correlate that with the base reflectivity. Okay, so maybe something going on up in that area. The main storm is further to the south. I'm just not really seeing anything going on in here. 0.9 storm relative velocity. We'll take a quick look at that. Here we see what looks like probably a little bit of shear here. This could be a couplet. You can see we got some strong outbound right there. This is on the order of about 41 out. And here we've got about 1 in. Okay, so we're going to correlate that with the base reflectivity. So that would be something embedded right there. Okay, well, I'm going to have to get my GR Level 3 color palettes optimized because these are not the best ones to be using. But anyway, that's the storm right there in northern Iowa, or in western Iowa. Let's continue on with our charts here and see what's going on. Okay, 700 millibars. We use this for capping, because we just kind of read the temperatures off, and this kind of gives us an idea of the mid-level temperatures. The warmer they are, the stronger the cap. We see values here of about 11 over Dodge City and 11 in Amarillo, so there's probably some good capping in place there. And then, of course, the 850 millibars. This is for finding your low-level moisture, the deeper layers of moisture up to about 5,000 feet, and the low-level jet. We can see we've got a very stout 60-knot flow right there at Dodge City this morning. So that's our moisture working its way northward just above the radiation inversion. My phone keeps going off. Let me take a quick look, see what's going on. Give me just a second here. Okay. Let me see if I got anything here worth showing you guys. Somebody's sending me a picture of some food at the store. There's like frog's legs and crawdad stuff in the frozen food section. So, yeah, where we are, we're kind of like east of Dallas, so we get a little bit of the Cajun food and the Louisiana influence here in the cuisine here. Okay, moving on along. Let's see here. We've gone through the upper level dynamics. So let's take a look at the cap. Let's look at the Topeka sounding. So we know that from the analysis that we've done today, Topeka is going to be ahead of the cold front. So this is the Topeka sounding for this morning. So this is what we would be looking at if we were planning a chase. We would see some very strong capping here. And it's very important that we have to modify this sounding for afternoon heating. Because you can see what they've done here. They've kind of used a automated technique here for forecasting partial lift. And that's not going to be representative for afternoon conditions. what we want to do is we want to take the forecast high. And I don't know what the high was, but we can look at the values here. See here, over Kansas, we've got like a lot of mid-70s. I don't know what it was earlier today, but I'm going to go for maybe 78 or 79. That's going to be about 26 Celsius. So we start out from there and go up to dry 80 about like that. And then we take the average lowest 100 millibars and find the average mixing ratio line. That's these things. And that gives us our LCL, and that's going to be right there. So there you go. There's our preliminary look at what kind of parcel we're looking at for later in the day. Now we do have to account for advection. Maybe we're bringing up some very moist air from Oklahoma. A mosquito in here. Give me just a second. Okay, to account for advection, let's take a look at the dew points that we have there in Kansas. Like a lot of low 60s. If we account for a little bit of higher moisture coming in during the day, we're going to come up with a parcel kind of like that. So now we're getting a little bit more CAPE out of the atmosphere and a little bit less convective inhibition. And then, of course, we can also account for erosion of the cap. Now, some of the erosion is going to come from dynamic lift. When you get these short waves coming in from the west and causing some upper lift, you're going to get adiabatic cooling of these layers. You're going to shift the mid and upper parts of the sounding a little bit more to the left. Now, one way we can kind of see what's going on is to look at the forecast temperatures based on model output. You can't use advection because the flow is not horizontal aloft. Let's see. Yeah, here we go. Here's the 700 millibar analysis or forecast. You can see over central Kansas at the start of the day, this is the 9 Celsius line. And we go forward to about 10 and then to 1 p.m. Here's the 9 line. And then by this evening, you see how it kind of shrinks. And in fact, here's the 6 line. So this looks like a drop of maybe 2 to 3 degrees Celsius. So we can take our sounding here and modify that based on that 2 degrees of cooling. So that's going to take our line here a little bit more to the left, kind of like that. So this is an example of the kind of modification you can do, and that can give you an idea what time your initiation will take place and what the chances of initiation are. And that's it's kind of a good idea to do that before you actually start looking at the forecast precipitation on the models. Because this will give you kind of a handle on what's going to be happening during the day and what the chances are of initiation. And then you'll be able to go up head-to-head with the models and have a better idea what's happening. Okay, so I think that's about all I have for the analysis. Then we're going to start in on the forecast. And since we have a lot of convective weather going on in the Central Plains, we need to look at some Got some of the mesoscale models like the NAM and the high resolution rapid refresh. Okay, so before I go further, let me take a look at the chat. And man, I'm not going to be able to go through all this chat. Let me just kind of scan through it real quick. Okay, Ryan mentioning just south of Lincoln, Nebraska, they had a very large rotating wall cloud pass over earlier today. Mike Estwick mentioning the Plainfield, Illinois tornado had like 7,000 joules per kilogram. Yeah, Plainfield, that was back in 1990. That was quite an amazing storm. Unfortunately, that was... I'm trying to remember the warnings on that storm. I think there wasn't too much lead time, and there was some loss of life on that storm. Does anybody know of good radar apps for cell phones? Yeah, that's a great idea, guys. Radar scope. Let me bring up my radar scope and we can look at that Des Moines storm. In fact, let me bring it up on my tablet. Give me just a second here. Okay, radar scope. Here it is coming up. And I believe I can broadcast this out to the computer. I'm not going to be able to do that right now, but I think maybe in a couple of days, maybe on Friday, we can put radar scope out and look at the storm that way. Okay, let me bring up Des Moines here real quick. Then I'm going to show you guys the images. I'm going to just kind of hold it up here. Okay, coming up now. Yeah, so we're waiting for the data to come up, but there it is right there. Hopefully that focuses. And there we go. This is a outstanding program. Sorry, it's bleeding the chroma key through, but there it is right there. I'm not sure if I can turn that off or not, but anyway, let me zoom that in and give you a closer look at that storm. So this has got a lot of neat tools. You can see it's got the granular level 2 data, and you've also got the important velocity products. So let me bring that up. Bringing up the velocity. Now, for some reason, I don't know why this is, but the storm relative velocity is very coarse. That's almost not very usable. But of course, it's better than nothing when you're out in the field. And then, of course, you have the standard base velocity data. I don't know if that's coming up, but yeah, it did. But it's bleeding through. Sorry about that, guys. So that's a radar scope, and I definitely recommend buying that. It is a very great radar program. So let's head into the forecast for tonight. This is the high resolution rapid refresh radar. Model data. This is the simulated radar. So this is what I would use in this situation from 0 out through 7 or 8 hours. And we can see that we kind of lose organization on these storms in Iowa, and they kind of disappear. But these storms here in Kansas really come together. and they kind of persist all night, and then by dawn, they are moving into the the central Missouri area. I don't know where that is. And then down towards around Joplin and Bartlesville. And this is along the front that's coming southward. You can see the lower thicknesses coming in from the north. So why did that stuff up in Iowa fall apart? I mean, why do we have this gap here? Well, it could be a lack of upper air support. Another thing we might look at is storm relative inflow. Let me take a look at the products here real quick. I'm going to switch over to dew point and wind, and I'll show you what I'm talking about here. It says we're coming in at 300 baud here or something. Anyway, this will probably take just a second here. It's probably loading in like 20 frames at the same time. But as far as storm relative inflow, we're talking about the flow from the south coming up to meet that front. You can see the front right here. And another thing is that we have the low pressure area right there just north of Omaha. And keep in mind, that's going to be moving to the northeast during the nighttime. So we should see some veering in Iowa as that moves to the northeast. Okay, so see right now the winds are out of the south about 10. And now they're veering, they're coming around to south-southwest at 15. Now, that is important because that's going to dramatically reduce the storm relative inflow. So any storms that are in this area, you're going to be shoveling a lot less moisture into them per unit of time. Meanwhile, down in Kansas, it looks like these storms are not that close to the low up in Iowa, so they're benefiting from some decent storm relative inflow there. Winds out of the south about 10, compared with southwest at 15 in Iowa. So this appears to be a storm relative inflow problem. And it could be also lack of upper air support. Let's take a look at that real quick. Okay, there's 0Z right now. Shortwave right there. And then by 9 in the morning, I think this is kind of being messed up by the storm activity there. It looks like we have another shortwave coming in right here, which means there's going to be a shortwave ridge in here. So I don't really know based on this, but I think this basically comes down to a storm relative inflow issue. Okay, so let's continue on with the forecast. Now I think we're going to start switching over to the GFS, and let's take a look at what's going to happen. Okay, guys, ready? Let's head into tomorrow's forecast. For tomorrow night, Thursday, main baroclinic cyclone has moved towards Detroit, trailing front. Looks like maybe down to Little Rock, and warm front up through New York there. So we got a little bit of a moist sector moving up into western New York, so maybe a possibility of thunderstorms in that area. I don't know. In any case, still got the Gulf open in Texas. So chances of storms continuing here. And then going into Friday, got a very good system coming together here in Texas. Notice the previous day we had this very strong thermal gradient here. That's the new front coming in from the Pacific there. So that comes together, and then by Friday evening, there's our cold front right there. So the Gulf is open. Low-level jet probably early that morning. And the best environment for severe weather is going to be probably Fort Smith out to Tulsa. Now, you can still get some severe weather along the cold front, but you're going to have more of that veered flow. That's going to be a problem. So that plus the very strong thermal gradient, which that means you're going to get more of a wedge type of forcing going on, more linear storms, and more outflow dominant storms. So overnight storms moving into Arkansas and Missouri, and then by Saturday night, things are moving into Tennessee. So probably a storm outbreak for Mississippi, the Memphis area. Front coming through Texas, cool air coming southward. It looks pretty quiet for Sunday, except if you're in North Carolina or Virginia. So there's our warm front right there in Virginia. New system coming together in the Pacific. So by Monday, like part of this is moved through the North Plains. Looks like a wave kind of moving like that. Whether we have storms up in that area is going to depend on how much moisture has been able to make it north through that area. So if I go back a few charts and take a look, it doesn't look like there has been much of a channel of moisture making it up into that area. See, we're under high pressure over the weekend. Where's the moisture? Well, it's been pushed southward. Some of it is starting to come up through Mexico right here. Then we go forward into Monday. Now it's starting to make it northward. And then by Tuesday, it's finally starting to make it up into Illinois and Missouri. So not much of a chance for recovery of the air mass for that northern system. Okay, so later in the week, Gulf is open. Another cold front coming south. We do get a few storms up there in northern Arkansas along the warm front. So then Thursday, the 27th, during the afternoon, looks like things start to fire as that warm front moves to the north there. So probably some severe weather possible for Wichita if the GFS pans out. And for Friday the 28th, like that system is lifted to the north there. The warm front moving up into Missouri. Then we get another storm on the tail end there in the Texas Panhandle. It looks like a new front right there. And then for the 29th, on Saturday, like the Gulf is open in the Mississippi River Valley, and probably a lot of widespread storms in that area right there along the cold front. Wow, some pretty good snow there in Ontario. Maybe a bit of a blizzard there along the Trans-Canadian Highway. Another system coming in from the Pacific for the first day of May, and then we get to the end of the pattern. Start to pick up the usual May thunderstorms in the Central Plains. And it looks like we have no shortage of chase potential as the first week of May progresses. Okay, that's probably about all I've got here. I've kind of talked myself out here for about a good 45 minutes. Probably a few of you are asleep there, but I hope you enjoyed the webcast. That's about all I got for tonight. We'll see you tomorrow. Actually, I'm probably going to be doing a late webcast tomorrow night. We've got dinner plans with the neighbors, so I'm going to do that. probably be doing the webcast about 11 or 12 tonight or tomorrow night. And then special webcast probably for Friday. I think that's going to be a severe weather day. So we'll see how that goes. Anyway, take care, guys, and we'll see you